We're delighted to have our second panel here on challenges to promoting innovation cooperation in a knowledge economy, paving the way from research and development to commercialization. And again, we have a great group here, which will be moderated by Mark Krumm, who handles innovation for us at the U.S. Embassy. And the panel includes Ross Harvey, the director from Sense-T in Tasmania, Mick Cardew-Hall, the Pro Vice-Chancellor for Innovation at the Australian National University, Dr. David Ireland, the General Manager of International and Innovation Systems at CSIRO, Dr. Shiv Kalyanaraman, the Chief Scientist at IBM Research Australia, and Tim Fawcett, the General Manager for Government Affairs and Policy at Cisco. So please welcome this panel to the stage.
Thank you, Matt, and thank you, Questacon, Ambassador Berry, and Dr. Chubb for your words earlier. As Matt said, I cover innovation policy at the Embassy. Before I came to Australia, I actually worked for about 15 years for a number of disruptively innovative companies, including MCR WorldCom, AOL, XM Satellite Radio, and a small network play that nobody's ever heard of called Light Squared. And the sad thing to me is that I would like to say that they were innovative for their time. It was only in the last 15 years. So basically, the lesson about innovation is not only to be innovative, but to continue to be innovative. I think we can all agree that the economy of the future, especially in this increasingly borderless world we live in, is the knowledge economy. There are a lot of buzz phrases that you hear these days on this topic, things such as, we need to do more with less, we need to be smarter, and my favorite, we must harness new ideas. As Ambassador Berry mentioned earlier this morning, there are a lot of worldwide issues that we need to address as a world. Education, environment, energy, food, health, poverty, security, clean water. The question is, how can we all work together, from governments to research institutions to academia to the business world, to connect the dots, make progress, and increase cooperation? How do we take these ideas that are out there as concepts in people's minds and in lab rooms all over the world, bring them to the fore, make them commercially viable, and in the process both solve these critical age-old issues, but also create jobs, not just jobs, but good jobs? In a nutshell, that's what this panel is all about. With that said, I really cannot imagine a better and more representative group than this one to address these questions. So to start off, much as like we did before, I'd like to ask each of you to give a brief introduction, background of what you deal with on a daily basis, and in the context of innovation, what's kind of hot in your world right now, and what are the challenges you face on a regular basis? So, Tim, maybe we'd start with you.
Yeah, hi, Tim Fawcett's my name from Cisco, and I head up our Government Affairs and Policy team, which really is about, most of my job is how we actually engage in debates like this. I think IT companies in particular have been pretty poor in the way they actually engage with some of the bigger debates around the things that are important to us as a country, whether they be economic, political or social. So part of my job is to try and get my teeth into this a bit. And in doing that, of course, you tend to disrupt your company a little bit or challenge some of the accepted thinking about the way we've always done things. And given this audience and some of the questions that came to the first panel, I think there's plenty of that occurring here today. So perhaps I'm in good company in terms of trying to disrupt the status quo. A little bit about Cisco, about 75,000 people around the world, 150 countries or so we operate in. Around a third of our employees are engineers, very, very strong investors in research and development, either buying companies that have already done the hard work and then we buy them and capitalise on it, or doing it ourselves. And we invested around about $14 billion last year, which is in line with a lot of other large IT companies and what they invest. Some of the other things that I do in my role at Cisco is work with our team on our networking academy. The Cisco Networking Academy is our effort to try and give back to the community by providing curriculum to not-for-profit education institutions. In Australia, around 24,000 students are going through a networking academy course in 2013-14. There's around about 196 not-for-profit education providers that are delivering that, and around about 600 teachers that are qualified networking academy instructors. So it's maybe one example that the Chief Scientist, Ian Chubb, was talking about earlier, where there are some good things happening in the industry that we can build on. One of the things I'd like to talk about a bit today is institutions. I think institutions are very important in helping to advance this debate around innovation and particularly around building science, technology, engineering and maths skills base. We have some great institutions in Australia. Our universities in particular are world class and trying to get higher up the scales. But there are a number of other institutions as well. I think the CSIRO has been mentioned, obviously, and Questacon is another good example. But I think a stronger focus on our institutions and the way we can actually enable them to be much more productive and more efficient in engaging with this debate. One I'd like to mention is the Business Higher Education Roundtable, which is a group of all of the universities essentially in Australia who've come together to find ways that they can better engage with business on doing research and development, and particular focus on innovation areas that are important to business. Mark, I'll leave it there and leave that on the table for discussion.
That's great. Now, next, Shiv. Shiv is a kind of a perfect panelist today. He works for IBM Research, so we've got the business side of things with IBM and obviously the research side, but he also, in speaking with him earlier before this all started, he told me that he had worked for 15 years in academia, so I think his perspective will be excellent.
Thank you, Mark. Yeah, I should also mention that I was born in India, but I spent 15 years in the United States. I'm a naturalized U.S. citizen, and now I'm here in Australia, right? So it's great to be here to represent both sides, and also academic and industry. So just a couple of comments about IBM Research. And IBM, as you know, is a 100-year-old company with a rich heritage of innovation, especially around the computer sciences. Like several of the companies that were represented here, you cannot be a 100-year-old company unless you adapt and innovate your way along. And these, there are major shifts, there are minor shifts, and it's very important for the company and organizations within the company to protect the technological future. So IBM Research helped develop technologies like the mainframe for the IBM company, computer science technologies like Fortran or supercomputers, and several of the systems innovations and fundamental advances that won Nobel Prizes in the areas of superconductivity, nanotechnology, and those types of areas. Most recently, in terms of the shifts that we are seeing and the adapting that we have to do is the shift enabled by networking. You heard from Cisco, and which is the internet and the emergence of cloud computing now offered as a service, and solutions to industry problems, whether it's the healthcare industry, natural resource industry, which are some of our focus areas here, offered as a service. So that's one of the shifts we are doing. The other is really the emergence of a new class of computing, which is driven by data and data analytics. I mean, we call that in IBM cognitive computing, and that's essentially is heralding a new age of computers, which is a learning computer, a computer that learns, interacts with humans in a natural way. So, and we believe we are in the first steps of that journey. IBM unveiled a computer called the Watson computer, and we now have a group as well. So I think I'm very eager to talk in this panel about some of the ways in which we work not only with ourselves but along with the ecosystems to both partner in fundamental research, partner in applied research, and partner in creating new business models to actually make that successful. Often technology by itself is not necessarily the problem. We are able to make progress in technology, but really how to put that together for success and apply so that innovation that matters reaches its potential is our biggest challenge. Thank you.
David, I think you're a logical next person following Shiv with the research efforts that you head up at CSIRO, which I just learned to pronounce properly this morning. Thank you for that.
That's right. And I'm next in line as well,
yeah,
so that makes sense.
Yes.
Look, thanks very much, Mark, and thanks, Ambassador, for inviting me and for organising such a great initiative. It's really good to see the topic on the agenda, and great to see the engagement with the students as well. Some really, really terrific questions this morning. So I work with CSIRO. The mission of CSIRO is to deliver profound and positive impact to Australia and the world by solving some of the really big challenges that we're facing. whether that's about improving the productivity of agriculture, whether it's about solving some of our climate change issues, or whether it's working in the manufacturing or ICT space. We work with Australian universities, in industry and organisations around the world to work on some of the big, complex, multidisciplinary challenges that are affecting the prosperity and the security of mankind. My role, I'm the General Manager of International Innovation Systems. It's a somewhat complicated title, but fundamentally I look after a lot of the international engagements that we have, which includes the US. And I'll talk a little bit about what we do with the US. But the innovation systems part is around working on innovation policy and working really closely with our universities and our research organisations across Australia to improve how we collaborate, recognising, and Professor Chubb touched on some of this earlier, Australia is too small. We don't have enough resources to do the type of science that we need to do if we all do it alone. There's intense domestic competition focus within the Australian innovation system, and I think sometimes that comes at the expense of being able to tackle the really big international challenges. I think if we can move to a much more collaborative-based science, we can start to build some of the critical mass that will enable us to compete on the global stage. So with the US, despite the emerging Asian economies, where I think by 2020 China's expected to have an R&D budget that's bigger than the US, the US still remains by far and away our largest partner in terms of science with CSIRO. We work with a range of universities across the University of California system, Caltech, MIT, University of Arizona, I could name a lot. But with US partners, we published about 480 papers last year, which is about 20% of our total publication output is with a US research partner. We also work with organisations like NOAA, the National Oceanographic and Atmospheric Organisation, to gather data to predict climate change and to understand how climate change is going to have an impact on the economy, but also on people's lives. We work with organisations like GE and Boeing and DuPont, and we have people based in the US to facilitate those relationships and to help support the R&D that underpins that. You asked me to talk about some of the challenges that I see in the innovation system. I spoke just briefly about a critical mass problem that Australia faces. We're 2% of the world's R&D system, and I think if we want to compete for the other 98%, we've got to get a lot smarter about working together so that we're big enough to be visible on the global stage. So that's one of the challenges. I think another challenge that Australia faces is our inability or our lack of ability relative to some other countries like the US to translate some of the fantastic ideas that we come up with and to translate those into products and services that can have an impact. And the Chief Scientist's Office last year, I think it was last year, you spoke about that we don't necessarily have the right people in the right places, that when you compare Australia to the US, about, I think it was 80% of the higher degree research graduates in the US work in industry, whereas in Australia it's 20 to 30%. And so we don't necessarily have the people with the skills and the capabilities to not only do the research in industry, but to pick up the great ideas that are generated within the university system and to do something with it and to absorb it. So that's a challenge. I think another challenge that Australia, and this isn't peculiar to Australia, is that the challenges that we're facing, think about climate change and biosecurity, population growth. You know, these are big, complex, multidisciplinary challenges that span political borders, they span scientific disciplinary borders, and a lot of the structures and processes that we have in place don't support that. In the past, a lot of the structures have been focused on driving single disciplinary science, and so we need to work out how we can shift that to much more multidisciplinary work. And the last challenge I'd note is that again, in comparison to the US, there's a significant lack of venture capital finance available within Australia that can help bridge the gap between what the government can fund in basic research and then what the bigger private equity institutional partners will be able to fund once it's to a significantly low enough risk profile for them to pick up. Venture capital fills that really important gap, and I think that's a challenge for Australia. So thanks,
Awesome. Great, thank you, David. So Ross, you're next, and to introduce you, I spoke earlier about needing to do more with less. Those aren't my words, and also working smarter. Well, I can't think of a company that's helping companies and businesses and working smarter than SenseT. I read some things about SenseT, and basically they take data points and all sorts of things about weather and crop yields and whatever else, and they put it in a blender and they call it this data smoothie. And the end result is farmers and winemakers and people who have dairy farms can work more efficiently in a quicker way, and also importantly, along another of the themes that we've talked about from some of the questions today, that's less harmful to the environment. So if you could expand upon that a lot more eloquently than I explained, that would be great.
I don't know, I reckon you did a really good job there. Look, it's fantastic to be here, and thank you, Ambassador, particularly for convening it. It's terrific to be here and with such a great audience, with so many mixed backgrounds here. It's also great to be on this panel because first thing I should say about SenseT is it actually is a knowledge infrastructure that we're building, and it's being done in cooperation. It's fundamentally about collaboration, and we collaborate with every single one of the organisations on this panel. IBM helped us get going. We have a partnership with CSIRO. We have researchers from ANU who are leading some of our research, most noticeably a new project we're looking around freight and logistics. We're talking with Cisco about how do we make the Internet of Things, the Internet of Everything real. And so we are fundamentally, I'm based at the University of Tasmania, and we're fundamentally about how do we create a knowledge economy of the future? And how do we do it in a way that's open, that, picking up David's point, actually looks at how we bring data scientists together with people who are experts about agriculture, with community, with end users to address real problems. And Ian, I love the challenge you threw out to us. You know, Australia needs to focus on what are really big needs and what are we really good at. Well, I want to chuck a really big one at you. We have to produce as much food in the next 40 years as we did in the last 8,000. We have to double the amount of food we have to produce just to feed people. And Australians are very good at producing food. And so this is an area that we are good at, and what we really need to look at is how do we actually do more with less. So we've got this enormous challenge ahead of us at the same time that we have no more arable land, we have unprecedented climate change. We know that within 16 years, we expect there to be 40% more demand for fresh water than we can supply. How are we going to make that work? And how are we going to pull a third of the world's population out of poverty? Now, there's a pretty big challenge for us. And technology and the knowledge economy is part of that. So let me give you a really concrete example. This is a project that we're doing with CSIRO up in northeast of Tasmania. And so the problem there is water. We've got 80 farmers working together on an irrigation system. And so the problem is what the regulator does is when the water goes down below a certain level, they're trying to protect the environment, so they're putting what's called a cease to draw order to stop the water getting below too low a level. Of course, that's a disaster if you're a farmer and you've got a crop that's sensitive with irrigation. So what we did working together with the scientists and with the data guys and with the community is design a real-time dashboard pulling together data from the Bureau of Meteorology, from the private sector, from the government, from farms themselves, and let farmers actually look at what was happening in the river and take action to stop the water flow going too low. So what happened is when they were tracking it through the summer and the water level, they started to see it dropping down below this critical level, the farmers themselves used this real-time dashboard to say, right, we need to release water into the stream, we need to change our irrigation patterns so that we do the poppies this week and we do the tats next week. And they actually managed collectively that water resource. Now, there's a hell of a lot of really clever science in all of that, incredibly clever science. But what really makes the difference is focusing on the problem and actually having the community involved in designing what the problem is you're trying to address and bringing all the smarts together to do it. So that's really a lot about what SenseT is about. How do we create a knowledge infrastructure that is available to researchers, to the private sector, to the public sector and the community to address real problems? Now, talking about scale, obviously relationships with big companies like in the States is really important to take these sort of ideas to scale. And we had our own roundtable a couple of weeks ago at Ambassador in Sydney with the World Bank where we just signed an MOU. That water project I just described has already been written to in a project in India because the issue of water supply is such a critical thing and we need to find new ways of addressing it. So that's really what SenseT is about, and I think the challenge for us, coming back to your challenge question, is how do we use technology, particularly this huge thing called the Internet of Things, right? $19 trillion opportunity, massive opportunity. How do we actually design it to be scalable, financially sustainable, so it's not dependent on government handouts, but also how do we design it so it's open? And that's really important because we know that innovation comes from new ideas, and often those new ideas come from small companies, from entrepreneurs, from researchers, from people outside the big mainstream. So we've got to design systems that let those folks into the data and be able to actually create new values. And you know, I think young people are an incredibly important part of this. And I just want to leave you with one final example before I finish. And that's we're working on a project with Rotary, not exactly known as the most innovative in the world in terms of the image that we have, but they are very innovative. And we're working on a project with a group of TAFE students from Hobart, and we're having a hackathon next weekend, so if you follow us, you'll see it. And they're writing apps for Papua New Guinea about how to actually get information to poor people about using local foods in a way that they can understand in a low literacy environment. And local food, we know that in the world, nearly 1 billion people suffer from malnutrition. We also know local foods can address some of those problems and help us maintain biodiversity. So how do we address food security using technology for some of the poorest people in the world? And a whole set of TAFE students from Hobart are going to address that challenge for us next week using our data and our data system. And that's the sort of thing that really, I think, is exciting. So
Great,
thanks.
that was wonderful. Thank you, Ross. Our next panelist is Mick Cardew-Hall, and Mick he works at ANU, so obviously we've got the education angle covered and what we need to do to prepare you young folks for the jobs of tomorrow in terms of STEM and that sort of thing. But also, Mick is involved. He recently helped sell an R&D kind of startup to an American company and was successful with that. And also, he's involved at ANU as working in an incubator capacity. So I think all those kind of themes tie together and help answer the questions that we're dealing with today. So Mick, if you could expand on that.
Thanks, Mark. And I'd just like to thank the Ambassador again for the invitation and congratulations to Mark to put together a fabulous event here today. I have a title of Pro Vice-Chancellor for Innovation. And so I usually start with, well, what's innovation? And I like a very simple definition of that, which is ideas effectively applied. At the ANU, with our great research intensivity and our fabulous students and our staff, we're not short of ideas. There's plenty of ideas coming out of not only the ANU, but all universities in Australia. The trick is to actually effectively apply them, and that could be in any sort of way. It can be commercially, economically, socially, and that's really where my space is, trying to get the effectively applied. And I think that's where, in the past, perhaps Australian universities have struggled in a number of respects. The way I like to segment it is that to do that, we really have to be working in collaboration with others to do it. Universities themselves can't do it, so we have to build a collaborative network. And then I try and focus in on, well, what are the stakeholders we're trying to engage with? And on one hand, they are at the startup level. We have a core of IP. How do we get that IP out there? So it's like a technology push. You know, a lot of businesses don't know what they don't know, and they don't know what the disruptive technologies are out there. So going to them asking what the solution they want to the problem they don't know they have is not always very productive. So we have to have a mechanism to push it out, and that's really the startup community. How do we build effective startup communities around our universities and also broadly within Australia? And for me, it's around how do I build an environment around the ANU, and we all hold up the exemplar as being what sits around Stanford, for instance. And there's a history there and the lessons we can learn from what happened there. So that's one element. The other element is then engaging with existing businesses. And this is where I think Australian businesses struggle to be innovative. By and large, most Australian businesses are small or medium size. We've heard some very large corporates here. But I think also what we've heard from is Australian subsidiaries of global corporates. And I think there's a certain dynamic around Australian business and industry, which means that for a university engaging with those small and medium-sized enterprises, there's some strategies and challenges that we have there. And it really goes to what David was talking about, is that the innovative capacity. How can we get these small companies, which are usually probably well run, but run very lean, and they just don't have the capacity to pick up innovative ideas? And I think this is where we can actually, really make some big inroads to try and improve the productivity of businesses in Australia. And the third area that I really engage with is the global corporates. a lot of the IP that comes out of universities in Australia is by and large of a very, very high quality by the virtue of the research that's done, by virtue of the investment that the government puts into the fundamental research, which is important to stimulate the whole economy. So it's about engaging with those global corporates. And what I find is that when we go out and we engage and we essentially pitch what capability we have and what we can do, there's a ready uptake. And I think we've seen evidence of that in this room today. And so to do that, you know, the other part of my job is to continually start networking, both in Australia but globally as well. So I spend a lot of time in California, New York, and in the US to try and build and strengthen those networks. And that's at the IP level, but really the capacity that makes it all work is people. And so for us, it's how do we actually then roll that back into the education programs? How do we roll it back into not only at the undergraduate level, but the postgraduate level, and also even for our early career researchers, how do we get them engaged in ways of really engaging with these global corporates and the small SMEs and the startups to build a culture change, and it's a culture shift that we're going through.
Mm-hmm. That's great, thank you, Mick. So it's time, I think, for questions, but I'll start with the first one. And let me ask Ross this question. So you mentioned before that basically everybody on this panel is kind of a partner of SenseT. So going back to the early days of SenseT, what were some of the, how did you kind of develop these partnerships when you kind of were just more of an idea and didn't have as much behind it? What were some of the lessons you learned? And if you had the luxury of hindsight, what would you have done differently?
Right. The lesson, I think the really important lesson we learned is that when you're working with technology, you have to really be careful that you haven't got technology-driven solutions trying to find a problem. I come from international development, the holy grail. You know, international development is littered with examples of people spending lots of licks of cash, and then when the money runs out, the whole thing collapses and disappears, right? So the holy grail for us is how do you actually do something in a way that is sustainable when the public money is turned off? And so when we started thinking about SenseT as a long-term knowledge infrastructure, the key challenge we said, we made a decision, we'd say that we were going to build an economy-wide sensor asset and never actually own one. Mm-hmm. And that meant that we had to talk to people about their problems. And so I think the key thing is starting with the problems first. I think in terms of collaboration is really, you know, it's a lot of it's about people. I think Mick's right, it's talking to people, trying to find where your alignments are. Learnt along the way a lot of difficulties with IP and business models, which can be very challenging to navigate, and so having a clear strategy about that early up is really important. And I think just being open and recognising that different people bring different things and trying to align incentives, understand the incentives in different organisations, acknowledge that and try to align them and come up with ways of working together that are flexible.
I think Dr. Chubb mentioned align as a key thing that we need to do to make all this happen in a smoother way. So we have any questions from the audience at this point?
My question was particularly for Mick and for David. Mick, in your educational capacity, and David, as your work as a scientist. Our current government has shown quite a lot of distrust, dislike towards science. The removal of the Minister for Science and from Cabinet, and also quite a destructive thought. And quite destructive thought towards tertiary education, as can be seen by the cuts to education. And my thoughts are on, my question, I guess, is what's your opinion on these cuts, and how do you think this is going to affect innovation in Australia?
I suppose that falls to me. So nobody likes cuts. I don't think anybody would like cuts. My thoughts are is that if we need to become more productive, we need to be more innovative, we need to really seed the research base of the nation, and which the universities are the powerhouse of that fundamental disruptive technology, the disruptive IP that's going to come through. So as an institution, and me personally, I think the government should be funding a continuous stream of fundamental research, which should be probably aligned to national research agendas, which I think have been well articulated. And so I think we should be looking at trying to encourage that. Where I think we also need to be trying to encourage is engagement is actually how do we then do the translational part? And I'd like to see funding of streams in that respect. With regards to access to education, I think it's shown that, you know, in order to have an effective and innovative workforce, you've got to have highly educated individuals coming through. So I can only be supportive that the government should be, you know, coming along and supporting that in the best way it can.
I'd just add one point to that, and I agree with everything that Mick has said. But what's the most advanced bit of technology that any of us own? It's probably our iPhone. And when you look at the iPhone, all the cool bits of technology, from the microprocessor to the touch screen to Siri to GPS to Wi-Fi to cellular networks to the internet, that was all funded initially by a government somewhere in the world. And that technology eventually then got translated and picked up and designed and turned into a product by companies like Apple. But there is a really important role that governments have to play in supporting very early stage research that does those fundamental breakthroughs. And then, like Mick said, then builds an environment that helps then the translation of that idea into a product or service that has an impact. So.
The only other thing I'd like to add is that, you know, you can take lessons from overseas, and I think, you know, it'd be good to take lessons from the US, for instance, about some fundamental restructuring of higher education there. And I think there's a lot we can learn, lots of challenges that the US are about to embark upon, I believe, which I think we could take lessons from. And I think we've only got to look at our Asian neighbours and seeing how much they're investing into their research institutions, their universities and their education programs to see what we're up against. And if we're up against competing with our Asian neighbours, which we are, I think that should tell us something about what perhaps some policies we should be putting in place.
Okay, great. I think I saw another hand. Yeah, right here.
I'm Travis. I'm from Narrabundah College. Just on a point that David mentioned before, with the multidisciplinary innovation stuff, do you think it's better to try and educate people in multiple different science and technology disciplines, or to have lots of people from different disciplines come together to try and solve all these problems that we're encountering?
There's always the experts on the science, technology, engineering, and math side, and there's always the experts on the business side and the communication side and the collaborative side, but there are very few people who kind of can do both. So if you can gain those science skills and technology skills and also become a great writer, work well with teams, all the other things, do great presentations and that sort of thing, I think you're going to be in good shape. And I'd kind of like to ask Tim, in working for Cisco, you know, what are the sort of the challenges you guys have in terms of finding those kind of people, and what kind of has been your strategy, if you will, whether it be training of your own people or how you go about finding people to do the jobs that you need to have done?
Yeah. Well, it's difficult, and I think anyone that works in the IT industry in particular will say that, you know, there's a skills shortage, and I know the numbers vary from different reports that come out, but I think everyone would agree that it's difficult to find the right skilled people. It's one of the big areas we focus on in the United States, actually, is around immigration and immigration laws, which allow us to actually hire people that have those skills from overseas, which has a whole bunch of other issues related to it. Nonetheless, there's a strong demand for it. I mean, I mentioned the Networking Academy, which we do, which is about skilling up not only potential workers for Cisco, but potential workers for our customers who buy our equipment and deploy our equipment and run our equipment and maintain our equipment, and our partners as well. So, you know, you're starting to think about a bit of an ecosystem here. It's not just about you as an individual corporate entity. Some of the other things we do in the United States, Ambassador, you would no doubt be aware of the White House's initiative, US 2020, which is a commitment run by the White House to increase the number of STEM students available or trained in the United States by the year 2020. And the way Cisco is committed to that in the US is to have 20% of our workforce volunteering 20 hours a year to provide support for STEM students, whether that be mentoring or campus visits or training through some of our training programs. I think that's an initiative and an idea that could quite easily be transferred here to Australia as a way where corporates, who often, despite appearances, are cash poor, but asset rich, and their main asset is their people. Any leader of a corporation will tell you that. So how do we harness the capability that we have at Cisco and other IT companies and any company that's in the science and technology field? How do we harness that asset? And one way is for people to be able to donate back their time and have a corporate support that and have a program to support that. So that's certainly one idea I'd like to see maybe come out of this conference, is the notion that we could have it in Australia 2020, modelled on what's happening in the United States, driven by the federal government playing that coordination role and collaboration role, and having corporates actually publicly commit to that, to have 20% of their workforce donating 20% of their 20 hours a year by the year 2020 to support STEM.
That's great.
I think I just think that's such an important idea. And, you know, I think in the knowledge economy, which is the topic of this session, is really data science, you know, STEM generally, is going to be combined in the future with existing sort of occupations. And, you know, people have this image, for example, in agriculture that it's you know, a low-skilled physical manual job. It's not anymore. It's a science job. And if we're going to drive productivity, it's really about IT. And the sort of IT that is coming into agriculture is incredibly important. And so we need to really inspire kids, particularly in rural areas, about STEM, how to get them engaged. And we think part of that is actually picking up this issue about having both STEM but also working on concrete problems and bringing people together to work on those problems and inspiring kids about what they can do through science and tech to address issues in their own community. And I think an initiative like, you know, being suggested would be a fantastic help in that sort of area of bringing together that IT expertise together with some of these emerging areas, and in particularly in schools.
Great.
Hello, I'm Jake Comager. I presented at TEDx Sydney about how the internet is changing STEM education, and I think we can all see that innovation and these fields of new forms of wealth are especially important for Australia in the future. How do you think that we encourage innovation through our education system?
Well, the internet is already changing education as a whole, right? As you know, through Coursera and online education medium where you can get courses, etc. online. So I think that's just the tip of the iceberg. There's going to be a huge amount of change in education driven by the internet. You know, I think one of the interesting challenges is how to go beyond you know, lectures and things like that to towards the other aspects that you get out of education, right? So one is the certification and getting a degree. The other is the social skills and the networks that you build. The other is perhaps connections and internships and ability to enter the workforce. So there are a lot of interesting ideas floating around in the education space, and certainly it's an area where institutions from Australia can get globalized, have a larger global reach, and vice versa. You know, any complacent institutions, you know, can get disintermediated by this trend, right? So, and it's great for any lifelong learner. I mean, I can tell you that in my daily public transportation rides, I do take Coursera courses in my. So it's a fantastic way to learn new spaces. So I think the shift will there'll be a shift towards learning and then applying that learning and then, you know, getting access to those networks of people so that you can get ahead in your careers and so on and so forth. So I think those are perhaps going to be what the focus will shift towards.
So I might make a comment. I met with Professor Sharma from MIT Mechanical Engineering yesterday, who's over visiting at the moment, and he delivered a lecture called Blowing Up the Lecture. And the concept is all around the flipped classroom concept. So no longer will we have lectures. What we'll have is all that material will be online, interactive over the internet. And then when we get together, we'll get together in small tutorial groups so you actually have a more constructive environment. And that sort of flips the whole concept of how education is going to be conducted. Not only broadly, you know, you can do these courses all over the world, but even on campus, it's going to really change the fundamentals of how we're going to do this. The one thing that we agreed is that probably he and I, who are probably at the same age, really weren't probably the right people to really work out how to do this, because we need to engage with people of your generation. Because the mode of learning, you guys have been exposed to ways of learning at school which were completely different to the ways of even just one generation back. And so I think there's this flip around. The other concept he came up with, which I thought was quite interesting, because I'm not entirely sure how we're going to incorporate it, is that In terms of learning, you've got an attention span of 10 minutes. So everything has to be done in 10-minute bites. Now, that really doesn't fit into a whole lecture, and I always wondered why half the class was falling asleep when I was lecturing. But now I know it's actually a physiological explanation. But what it does is that if you take that concept on board, which I think is probably true, and then you can actually design whole courses online around that, and then you have more meaningful engagements on smaller groups, you've changed your whole education paradigm.
Totally
Yep.
agree. Can I add one more thing?
Sure.
I reckon what we're taking that concept and add it to learning that starts from school all the way through postgraduate, problem-based, experiential, actually you're engaging with the problem, and interdisciplinary. You do those three things, you free up students from having to sit in rooms and just, downlump information and free them up to be creative across that sort of methodology. That's exciting.
And I don't know if you necessarily even need to be in a tertiary institution to be having those creativity moments. And I think there's a cultural challenge within Australia about supporting entrepreneurs more and encouraging people to be more entrepreneurial and to take those risks. And like Mick said, part of that is that starts back in school and how we're taught and how we're encouraged to be creative and to question and to look for different solutions to problems. I think there's a long way Australia has to go in building an entrepreneurial culture and one that's accepting of failure and that encourages you to fail and then get back in and give it another go and keep trying.
Yeah, one other thing I might add is also the need to get experience in an apprenticeship mode or on the job, things like internships. I think we have to find ways to scale those models up. Of course, through partnerships across institutions, that's one way to certainly do it. And I'd like to have an open invitation to all of you. If you come over to Melbourne, please come and visit us, and we'll be open. And I'll be happy to show you around IBM research and what are the interesting things we do there. And we do a lot of internships and those types of things with our partners, but we need to find ways to scale that up even more. So I think that those are probably interesting areas.
Okay, great. Thank you, Shiv, and everybody. I'm getting the signal from my fearless boss that it's Twitter time. So, Matt,
Well,
do you have some
actually, I think your question right there at the end really synthesized very well a lot of what we're already seeing on Twitter and from other questions in the audience. And I think we've done a good job. I think all the panelists have chimed in on that one. Tim, did you have anything you wanted to add there?
I'm good.
At the end? You're good? So thank you very much for asking the key question there at the end. Please join me in thanking our panelists.